Hey, we want to learn about pressure in a fluid, going down in a fluid, for example. And we're under pressure right now, 1 atmosphere of pressure from where we stand on the surface of the Earth. And you can see here, if we go up and down, several meters in elevation, we're still pretty much at 1 atmosphere of pressure, which is in SI units, that'd be 101.3 kilopascals, or English units, which is a little easier to understand for most of us, 14.7 psi. That means there's 14.7 pounds pushing on every square inch of our bodies. That's quite a bit. And it's amazing you don't notice because we're adapted to that. You'd notice if it wasn't there or if it changes, right? So maybe you've been swimming. I think most of us have been swimming. You've noticed that when you go down underwater, that pressure goes up right away as you go down. Yeah, goes down quite significantly. So here, when you're in the air, you go all around. Basically, the pressure stays the same. It changes just a little bit, goes down just a little bit as we go up. Start going down underwater. Well, now the pressure really starts going up. Okay, yeah, the pressure, 1 atmosphere of pressure. But what is pressure? We're talking about all this. Well, you have some sense it's some kind of a force, right? Here in English units, maybe it's pounds per square inch. Okay, so that's already giving us some idea of what this thing is. Let's go ahead and then see how we're going to define it. Pressure, we're going to go to define it, is going to be P, is going to be force per area. That's how pressure is defined. So here, if we have some cylinder, we're pushing on it with a force, and that has a surface area. It's being applied to some other surface here, some area. So here we're pressing in with a force over some area A over here. Then the pressure is the force per area. Let's say, for example, here we're pushing on this rod, on some sheet. Maybe this is a piece of plywood or something. We're pushing on it. Let's say that force is 2.25 pounds of force. That's equal to 10 newtons. 2.25 pounds is 10 newtons of force. Let's say the area is equal to 1 centimeter squared. So pretty small little area. That'd be like, say, the force of our finger. Maybe your fingertip might have an area of 1 square centimeter where it's pushing here. What is the pressure then? The pressure is the force per area. So here that will be 10 newtons divided by a centimeter squared, 1 square centimeter. Okay, so that's fine. That's certainly not wrong. Is it SI units? No, that's not SI units. So a force of 10 newtons per centimeter squared is definitely a pressure. But if we want it in SI units, what do? Well, what we can do is here we got the 10 newtons on top, and centimeters go pretty quickly to SI units, right? We just take 1 centimeter is 10 to the minus 2 meters. Centimeters 10 to the minus 2 meters, 1/100th. But here we have to square it. So what we have over here then is 10, I'll write it as 10 to the 1 newtons divided by 10 to the minus 4 meters. meters squared, and that's 10 to the 5 newtons per meter squared, which is also 10 to the 5 Pascal, PA, because a Pascal, 1 Pascal is Newton per meter squared. So that's how we define that, Pascal. Yeah, and we could, let's see, let's go back over here, FETSIM. If we go with, so we see here, if we go with atmospheres, oh, I gotta get the right button here. Where's my FETSIM? Yeah. So see here, if we're at 1 atmosphere, what is the metric pressure? It's 101.3 kilopascals. Okay. So we'll go, let me go back over here to GIMP. So we can see then from our simulator that 1 atmosphere is equal to 101.3 at 25, but anyway, I'm going to stop right there. Kilopascals, or what's a kilo? It's 10 to the 3, so that's oh well, let's just write it like this: 1.013 times 10 to the 5 pascals, or newtons per meter squared. So we could see that 1 atmosphere is basically close to 10 to the 5 pascals, or 10 to the 5 newtons per meter squared. So coming back over to our problem here, then our pressure that we found here is 10 to the 5 pascals, right? Say if that's this finger going on here, so say we're pushing with 2.25 pounds of force, the area of our fingertip is a centimeter, then that's the equivalent, basically, or roughly equivalent to 1 atmosphere of pressure. We're putting on that guy. 1 atmosphere of pressure. Great. Great. Well, now if we're going to be a syringe though, so that's a finger, right? Pushing with 2.2 pounds of force. So 1 atmosphere of pressure. I've already got one of those on me right now over every square inch of my body, as do you. Evidently, pushing on it with the finger like that is not going to break through the skin. If we want to get through the skin with the same force, what are we going to have to do? So force is given. We want to get into the skin. We want to increase the pressure. What are we going to do? Decrease the area. So let's say, so this was that example. Then let's try another example. The force stays the same, but let's try instead an area equal to a millimeter squared, a square millimeter. That's a tenth. A millimeter is a tenth of a centimeter, or a thousandth of a meter. Let's see what our pressure is now in that case. Okay, so in that case, then the pressure will be equal to 10 newtons divided by a millimeter cubed. Okay, and again, that's not wrong, but it's not in SI units. So to get that in SI units, what can I do? I can go, okay, 10 Newton divided by, and remember, a milli is a 10 to the minus 3 meters, but that's got to be cubed, squared. Squared. It's not a volume. It's a surface area, not a volume. So now, so a square again. When the square hits everything inside the bracket, right? So it hit the 2, became a minus 4. It hits the meter, becomes a 2 squared. And here the 2, so what's the rule with exponents? They multiply. So that's going to be a 10 to the minus 6. So this is going to be like a 10 to the 1 Newton over 10 to the minus 6 meters squared. That's 10 to the 7 newtons per meter squared. Or our pressure is 10 to the 7 Pascal. That's got to be a cat P. And that's pretty close to 100 atmospheres of pressure, right? 10 to the 7 is like 100 times 10 to the 5. So that's about 100 atmospheres of pressure. It's equal to our pressure. Will that be enough to break the skin? Well, a 1 millimeter, it'd be, I don't know if I could draw a little millimeter. Maybe that's what it looks like. A square millimeter. That would be a pretty blunt needle, wouldn't you say? 2.2 pounds of force, not unthinkable for a finger. If you pushed hard enough, it would definitely go through. It would hurt. That would definitely hurt. But we would probably want an even smaller needle than that. Maybe like a tenth of a millimeter. I'm not sure what the surface area of a needle would be, but maybe we could consider that in an exercise. Yeah, that's a good idea. Okay, let's think about that exercise before we do the next video.